I would like to understand from each of you, like, what's your exposure to generative agentic AI? So, hey, I'll go with Aditya. Maybe quickly, again, for example, 10, 15 seconds. Aditya, can you please tell me what are you doing with generative agentic AI right
So as of now, I think I'm using some of the GenAI tools that are out there, like ChatGPT and Claude and all of these, to kind of try and do some kind of pet projects as well as some research for some office work.
now? All right.
Um, what I mean by pet projects, like try and build some app or do something of my own on the side. So yeah,
So when you say
that's
try building the app, do you use vibe coding also using generative AI?
yeah. So basically, I'm using VS Code and
Mhm.
Copilot that's
Mhm.
integrated in it, as well as sometimes ChatGPT and Claude to kind of figure out what code needs to be written to develop the app.
Okay, cool, cool, amazing, nice. How about you, Silky? All right, we'll move to Rajaling. If you are in a car, maybe you can say so.
Uh,
Yeah,
yes,
I'm
uh, I'm just using for ChatGPT only. I'm using just for
Mhm.
communication.
Okay,
I haven't started using any AI tools.
all right, cool, no worries. How about you, Silky?
hello.
Yeah.
Yeah. So I think my understanding is also same that like as a product owner and as a product manager, how do I use the how do I use the Gen AI, especially in terms of like applying. I mean, I'm pretty new to this one. Not, I won't say that I'm very like I don't have like very good hands-on on
Mhm.
chat gpt or any of the AI tools, so it's like I have to start with very basic. So
Mhm.
it is something like I'm looking for the use cases definitely, but also something more fundamental is something which I will be more keen on for this session.
Got it, got
Yeah.
it. And we have Nandakishore.
Yeah. Hi, Raghavendra.
Hey,
Same with me, same as Silky and Rajalingo. I've not used them a lot. I'm just willing to explore.
cool, cool. All right. So see, great. So this teaching, this philosophy of is that basically we will be introducing a problem so that you don't learn concepts in isolation, and everything basically whatever you learn here is actually coming from real world experience or implementation, right? So we will dive into the study case study. This is a case study based teaching approach. We will cover all the topics in detail, whatever APM is required. Since we are not doing the engineer focused course, of course, the details are limited to what a PM should be able to know. So okay, let's start right now. Okay. Anytime you want me to stop, please stop and ask question, right? So hey, this session, this next 6 or 7 case studies that we will be taking are completely focused on generative AI and agentic AI, right? And here, what we are going to learn is we are going to learn from um, one of the fairly complex and fascinating AI implementations in Indian tech industry, which is Swiggy's customer support. Right now, of course, we will be going to slides and material, but before we dive into this kind of architectural programs and technical concepts, I just want you to imagine something very real, very relatable, and I'm saying something that we all have experienced. Right? So we have ordered food from Swiggy and Zomato. We have used services like Zapto, Blinkit, Insta, art, and all these things. So let's say if you order from Zomato and Swiggy, and sometimes let's say so you order, for example, chole bhature, okay, from some of your favorite restaurant, either via Swiggy or Zomato, and of course, once the order, let's say delivery arrives and you open the box, you might have noticed that something is not correct, right? Might be chole might be cold, bhature might be little soggy, some of the cutlery might be missing, or you ordered, let's say, a drink which didn't arrive, but it's still it got charged. So there can be so many things that can go wrong, and of course you're frustrated. And in that case, you go and open the Swiggy app or Zomato app and you start typing a complaint. Okay. Now, generally, what happens is that you are not going to type in perfect English. I mean, most of the people, right? You are going to generally speak or type in a manner which how you would speak generally in day-to-day life. For example, many of the users, they generally write something like, hey, order late आया है, थोड़े ठंडे थे. I hope you all can follow something they write. So order late आया है, थोड़े ठंडे थे, भटूरे सौगी थे, मुझे रिफंड चाहिए. और अगर रिफंड फॉर एग्जांपल नहीं मिलता है, then in that case क्या रेस्टोरेंट मुझे डिस्काउंट दे सकता है? Something like that you try to write. Of course, you might want to write this in one line, or you might want to divide it in multiple lines, right? Or different sets of conversation. But generally, our customer complaint is always a mix of Hindi and English, because we tend to assume that the person that basically we are talking to is kind of an agent or kind of bot, human being, right? Now, basically, just take a pause and think about all the customer complaints or interactions you have done through these conversation assistants in Swiggy or Zomato. There might be one message, but there can be multiple requests that are hidden inside. Right? So first, let's say you complain about late delivery, then you complain about food quality, for example, chole being cold and bhature being soggy. Then you ask for a refund, and then you are asking whether you can a discount or some from the same restaurant, right? Then just imagine what are you doing here. You are actually having multiple purposes in the same request. You are presenting multiple intents, right? So you are mixing Hindi and English in the same sentence, which we call as Hinglish. You're doing code mixing, that's what we call in a technical term. Okay, you are using colloquial phrases, for example, bhai or bilkul or for example, some other phrases. So, and you expect that the bot will understand. Right? Expectation is that Swiggy will understand everything. Pull your order, check the policies, process your refund, and respond. And of course, you expect all these to be done in, let's say, 10 seconds, 30 seconds, like in very real time, right? No one wants to wait while they are talking to a customer service agent. So here is the skill that makes this truly mind-bending. So I was looking at an interview in 2019 interview from US Story, and the interview was from Swiggy's head of delivery and data science, and he revealed that Swiggy processes more than 40 billion data points every single day. Okay, and that's not a typo. It's like 40 billion unique data points flowing from customers ordering food and delivery partners completing those orders. Now, according to the prospectus that they filed with SEBI in September 2024, Swiggy so far has more than 112 transacted users, which means the users that have completed at least one order. And they operate across 681 cities in India, and that number has grown significantly from the time I have started tracking this company online. Now, their customer support roughly handles like 200,000 customer inquiries per day, according to a Pubnum's published study on infrastructure. And at peak times, they see thousands of concurrent sessions. That means thousands of frustrated users talking to the customer support. Now, just imagine this linguistic challenge that this thing poses. First of all, this is very uniquely Indian, and that's why I took this case study. So according to some human development survey done by University of Maryland, only 4% Indians communicate fluently in English. Rest, they can 16% manage with some little English, and which means for vast majority of Swiggy's users, communicating in pure English is kind of uncomfortable or impossible. So they always use like a mix of local language, their own language, or English, right? So also the same chole bhature can be typed in different kind of ways in English. For example, the spellings can change. There is no standardization. Biryani can be addressed and written in different manners. So the AI has to understand all of them. And this is basically the problem that we will be trying to unpack today. So through this one case study, we are going to learn 7 core generative AI concepts that appear in virtually every product that you will ever work on. So whatever you are learning today, it will be applicable to almost all generative AI or agentic AI products. Right? So you have to understand very well, and please ask me anything. Before we dive into the problems, let me give you some more context on how massive this operation is, because the scale changes everything in AI. Like I know so many engineers in Bangalore and product managers that I hire. They actually are pretty good in developing a POC. Some are good in developing a prototype with 50 users. But if I tell you, you have to develop this for like millions of users, and this changes everything, right? So we as a product manager have to develop enterprise grade systems, and that is what we've been focusing on. We are not going to learn just theory with the understanding that, okay, we are going to do POC, we are not, we have to build real products that are actually used by real users, right? So now, Swiggy, as you know, controls more than 40% of India's food delivery market, Zomato being the market leader. Okay, now Swiggy processes as a kind of 1.58 million food orders daily, according to some latest statistics. On the top of that, the quick commerce arm, which is Instamart, it handles another 482,000 orders per day. Now, that's roughly about 2 million orders flowing through the platform every single day, right? And there are thousands of restaurant partners across like 681 cities, delivery fleet, hundreds of thousands of people. So the scale is massive, massive, right? So it's not just being a small startup experimenting with AI. They are actually running enterprise grade AI, which even sometimes most Silicon Valley's companies also don't do. So it is a great example, right? So now we are going to understand how do actually they have dropped this resolution time from several minutes to few seconds, right? And this data, I mean, I will share that later, but many of this research is published in different blogs as well that you should go and read. For example, Databricks engineering blog is a great example. I hope you learned that after this class. Now, basically, I will be showing you the success, but of course, success didn't come on their first try, right? So they have developed multiple versions, and we will learn through that thought process that what goes into version 1, why it failed, why they chose version 2, version 3, version 4, something like that. Of course, I can take version 4 as the first example, but we are not going to do that because that's not how real learning happens. As a product manager, you are not just going to build AI systems, but you are also going to inherit AI systems that are not working well, right? There might be some other teams who have developed the AI systems, and now you have to fix their problems. So you are going to be asked to improve existing systems. And if you are going to improve existing systems, of course, you have to learn how to diagnose and debug those existing systems, right? And you are going to sit in the meetings where engineers propose, say, 3 different approaches, and you need to understand the trade-offs. So this is what this session is about. Okay. Now, let me go to the problem statement. So any questions so far? Please let me know.
Hello.
Yeah, go ahead.
Yeah, hi Raghvendra.
Yeah,
Raghvendra, before we dive into this,
yeah.
just wanted to understand. So basically, uh, till now,
Mhm,
uh, like in the past,
mhm.
companies did have customer support, right?
Yeah,
I
yeah.
think it was mainly rule-based agent, right?
Mhm,
Not necessarily an agentic AI, right?
mhm,
So, uh, if let's say as a product manager, how
mhm,
do we decide, what are some things that to keep in mind while deciding that, okay, we'll go with the traditional rule-based
mhm,
system,
mhm.
or we'll go with the agentic, like AI based or LLM based system
Yeah,
for
yeah.
building anything, right? For any
Perfect,
use case.
perfect. You will have this query answered within next 10 minutes, right? Okay, so just please wait. Yeah. Okay.
Okay.
So yeah, cool. Thanks for any other questions.
Also, is
Yeah.
customer support the only avenue that Swiggy has been using this, or is there any other vertical as well?
No, there are many verticals, but customer support being the biggest of that, I believe. There. Okay. So for example, I will just very quickly give the example. So one of the study also said, for example, that hey, when you let's take Airbnb and Swiggy for example together. Okay. So when Airbnb founders noticed that the photos that they put on Airbnb actually decide how many kind of bookings are made for that particular venue, right? Same goes for Swiggy. So in Swiggy also, if you do not post good photos of, let's say, the food that you're offering, or the menu is, let's say, not clear, then in that case, also orders drop. So there could be an AI which is actually
ఒక
at
పది
least,
పదిహేను నిమిషాల్లో వస్తాం అమిత్ తింటా
sorry, yeah.
అవసరం లేదు వస్తా 10 minutes.
All right, so maybe, yeah, so there could be an AI which is also using computer vision to analyze the quality of the images and all these things, the quality of the menu. So there could be different AIs serving different purposes, but right now for this thing, because of the scale of this, we are focusing on the customer support. Yeah. Okay, we will move to the master problem statement. Okay, now the problem statement is very generic. Okay, how do you provide intelligent, hyper-personalized customer support for over 100 million users across nearly 700 cities, processing millions of orders per day in a country where only about 4% of the population can converse fluently in English. Dish names have no standardized spellings, and customers expect resolution in under a minute. Yeah. This is what we will be doing it. And according to right now one question that was asked, why not traditional rule-based chatbots? So I'll tell you, but traditional rule-based chatbots couldn't do this, and I want to be specific about why. Because understanding the limitations of traditional systems is very crucial to understanding why generative AI was necessary. Okay. Now let me pull the slide. Okay. So for example, here you can see, let's take an indicative figure. Okay, that there are roughly 200,000 daily customer support queries. You can read on the slide. There could be different queries actually for different issues. There could be delivery and quality issues. For example, food came late, cold or damaged. There could be missing items. It was charged but not received. There could be wrong items, and we always see on news like, hey, some vegetarian guy got a non-veg and it created, of course, some issues there. So delivery dietary violations will be there, incorrect orders are there. There could be packaging problems. For example, sometimes things are spilled, there is leakage and damage. Of course, there is a request for refunds and cancellations. Some pricing confusion could be there, and there might be some restaurant-related questions, right? So we have actually classified these queries into different kind of buckets. Okay. Now, just for the time being, look at this part as like intent. Of course, when the customer queries comes, we have to understand what is user trying to do. Okay, so let's just see this example. Order late आया, छोले ठंडे थे and refund चाहिए. Very simple query. Right? Order late आया, छोले ठंडे थे and refund चाहिए. But what is user trying to do? So that what user is trying to do is called as intent, and here we have different intents. Okay, so let's see. For example, in delivery problems, okay, where there could be multiple intents in one message. There could be an intent about late delivery, where the user is complaining about late delivery, about cold food or refund request. Sometimes it could be where the user says, let's say, fries order kiye the nahi aaye, bill mein charge hua hai. It could be an intent about missing item report plus refund calculation. It could be, of course, about dietary violation. You can quickly read this part, but it is very intuitive because we all have experience in some manner or another these things, right? So when there is a dietary violation, there is a different kind of risk, which is about customer retention. When it is about escalation packaging, sometimes the intent is about asking for partial or full refund. So then there could be financial queries where the question could be something like, okay, restaurant ne accept nahi kiya, refund kab milega? Or billing confusion, where the customer is expecting some kind of dynamic pricing explanation, where delivery fees sometimes changes, right? There could be customer query about feedback and information. For example, quantity come thi, maybe customer is expecting a little bit more, and then he asks for discount that, hey, I ordered for 2 people, but the food was not enough even for 1 person. Then can you at least give me discount, or so that I can order again, right? So the feedback is about quality monitoring. And sometimes the information right now, at least on Zomato, there is a toggle, right, which can say, okay, this restaurant is pure veg. But prior to that, we have to know that, hey, restaurant is pure veg because it shows kind of mixed on Google, right? So these were also some of the queries. So, and of course, there are many code mixing, which is different kind of languages mixed. For example, in English, it could be said very late, but in Hindi, we said bahut late aaya, or thanda khana, or refund do. So there are, of course, kind of Hindi and English mix, and most of the queries, like 96% of the users, mix languages naturally. Now, if we are going to implement AI, basically what AI must understand is AI must understand different issues, verify them, understand how to respond and execute. And all this has to be done within 500 milliseconds, which is like half of the second, with more than 99% accuracy. So this is the target metric that Swiggy is actually targeting for. Okay? So this is what it is. And before I go into this, I will try to answer that why traditional rule-based systems cannot do. Okay. Now just imagine, if you are going to do rule-based chatbots, how many rules are going to write? And for what many situations? especially when there is no standardization, there is so much linguistic diversity. Everyone is expecting hyper-personalized personal care. You cannot. Let's imagine, even if with the best AI system, you reach a 90% accuracy. Okay. Then also, there will be more than 20,000 errors if we are taking an indicative figures of 2 lakh people asking questions daily, which means every month there will be more than 6 lakh unhappy customers. So, and if you move to 95%, then there will be 3 lakh unhappy customers. And if you move to, let's say, 99.9%, then there could be, of course, 6,000 unhappy customers, which is kind of acceptable. So with every percentage point of accuracy, you may get a lot of impact. So with this scale, every single point matters, and you need the best AI to actually operate such kind of problem. Now, the key takeaway is that whenever you talk about customer support, there is a lot of hidden complexity with language detection, intent extraction, order verification, etc. Okay. Before I dive into this, so this traditional chatbots work on what we call intent classification with keyword matching. Okay, I think I might have some slide on that. Let me pull that one. Okay. Yeah. So for example, when you go about the keyword based methods, if in this case, which is bhai chole bhature thande the, please kuch karo, there is no mention about keyword, there is no mention about cold food, there is no mention about compensation. So essentially there is no keyword, right? What we need to understand is we need to identify the intent. We need to understand what the user is trying to say, and that is where the traditional system completely fails. Okay. So sorry, I couldn't catch who asked this question, but can you please confirm if you could understand why traditional systems won't work here?
Yeah, Raghavendra, Aditya here. So I understand to some extent, but basically, see, in Swiggy also, there are a
Mhm,
couple of buckets where you can, like you mentioned, right, that you can
mhm,
categorize each of the query to.
mhm,
So it could be regarding refund, it could be regarding
mhm,
cold food, it could be regarding delays,
mhm,
spillage, all of these things, right?
mhm, mhm,
So in keyword matching also, I think like what I gather from this discussion is that okay, because of the language diversity that we have, right?
mhm,
It's very hard to maintain keywords for each of these buckets in for all the different languages, right? But
mhm,
otherwise, if in a country which is mainly uniform in terms of language, let's say US or Europe or I don't know, like some country which uses mostly English, right?
mhm,
So for that particular place, so let's say I have a food delivery app there, right?
mhm,
Over there, would it be suffice to say that okay, if I have a keyword matching kind of like rule-based application,
mhm,
which is essentially you know uh, and I have like categorized keywords into different buckets
mhm,
of the most prominent language that is used there.
mhm.
Then I'll be able to satisfy most of the use cases,
Uh,
or is there some other reason as well for which I might want to go for
for AI, yeah.
yeah.
That is the question. Yeah. So okay, generally, historically, all of these systems were basically rule-based systems, right? Historically,
Mhm.
and we can't say that they help you, but the thing is, just look at this kind of metrics chart, right? If you are
Mhm.
serving, for example, I mean, hypothetically speaking, 1 million users every day, or 1 million customer queries every day, okay, and even if 1% error happens, that there are a lot of unhappy customers, right?
Yeah.
Yeah. So if there is a uniformity in language, and if people talk in more or less same manner or homogeneous manner, of course, you would have higher percentage that can be done with rule-based systems. But still, language by nature is inherently kind of not very kind of you know say standardized way of asking
Mhm.
for every single thing, right? So, for example, generally, I'm not very as a human, most of us don't want to ask for refund directly. We sometimes want to give some reasons like, hey, the order was late or some items were missing, but we kind of expect that, okay, can the person give at least partial refund or some discount coupon, right? So I think understanding so if the person is very straightforward and can say refund, then yes, the traditional rule-based systems will pick up. But most of the time, the queries are not generally very direct. And of course, there are multiple intents within the same message. Okay, because we are also trying to explain why we are asking for the action to be taken. So there could be multiple rules need to be combined if we want to make traditional rule-based systems successful. Yeah.
Mm. Because like some of the chatbots, I think in the traditional system, I think one of the ways in which they try to cut down on the different types of queries is by providing some options, right? So the moment you open a
Yes. Yes. Yeah, you are
chat,
right. Yeah.
yeah,
Yeah.
so they'll just give you a list of options and you just have to
Yes.
choose from them. So
Yeah. Yeah. That is a decision tree based
yeah,
approach actually.
yeah, yeah.
Yeah. There they give you 5, 6 options and they say, okay, if you want this, you go there, you go there, right? Yeah. So
Mm.
this is generally a standard approach in many of the cases still, because AI is generally expensive, right? So yeah, you are right. Especially if the scope of the support is kind of limited, I think decision tree approach is also something you must try maybe as a first one and see what is the accuracy that is coming from. Good catch there.
Yeah, got it. So it's more of an so what I gather is it's more of a one thing is okay, deciding first, and then, or it's more of a iterative thing. So first you decide to
Yeah.
go with the traditional approach and see, okay, what metrics are being met, and then if you're not able to satisfy some percentage of users, then you decide, okay, fine, let's go with the AI
Yeah,
solution.
that's always the case. I mean, that is the go-to approach. I mean, always choose the approach you can implement the fastest manner, do experimentation around it, and iterate from there, right? So that is why we are suggesting that okay, we will be discussing about different kind of revisions Swiggy made from version V1 to V4 and how they took a step-by-step approach and they built on the top of each other, right? So that is the approach. Yeah.
Got it, got it.
Cool. All right. All right. So basically, now we understood that why traditional systems might not exactly work, right? Because of so much complexity here. And that is where the concept of embedding comes into play. Okay. So let's go back to our kind of chole bhature complaint, right? Where they said, okay, order late aaya, chole thande the, bhature swami the, or some items that were not delivered also got charged. Okay. So the first challenge is simply understanding what this message means. And I want you to appreciate why this is hard because it's not obvious until you actually think about it, right? So traditional keyword matching would look for words like late or refund or complaint. But look at our message. The word refund does not appear anywhere. Okay. Complaint also doesn't appear anywhere. So if you're doing keyword matching, then you will miss this entirely. What we need is a semantic understanding, the ability to understand meaning and not just words. Okay, and please remember what I am doing, the concept of embeddings. Okay, this is where embeddings come in, and of course I'm going to explain this concept in a way that will stick with you. Okay, now basically embeddings. Okay, so embeddings is, for example, let's look for this common intents in food delivery app. Please quickly read, for example, burger missing tha. Okay, the intent is about missing item complaint. Order code क्यों apply नहीं हो रहा है, which is about promo offer query. Restaurant veg है, which is about restaurant information query. So depending on the message, the intent is different. Now, of course, same intent can have different expressions. Like let's look at the refund request. Okay, in refund request, we can say something like, okay, मुझको पैसा वापस चाहिए, या order cancel करके refund दो, money back please, खाना खराब था, payment return करो, order was cold, I want my money back. So just look at this. There are so many infinite variations to these finite intents. Intents are finite. There are only like how many 6 intents, but the same intent can be expressed in different expressions, right? So this is the fundamental limitation of traditional chatbots that we just discussed right now, that keywords are missing there. So what we need is semantic understanding. So traditional systems will break when the context is missing. For example, user implies asking for refund, but without actually stating it explicitly. Or there could be spelling variations, there could be code mixing, and there could be expression diversity. So same meaning can have different words, right? And where this is their traditional systems will break. Now, for one intent, there could be many forms, as we just discussed here. So solution requires semantic understanding via embeddings, which means not keyword matching, but meaning extraction. So the first problem, so as I said, we will be discussing here with 6-7 problems in this class and learn these concepts. First sub problem is intent classification. How does AI classify the intent? And it does by using embeddings, okay, which means converting text to mathematical representations. Okay, so just look at what embedding means. For example, just imagine a text, and we have ways to convert text to vectors. So think of it as like a sentence and coordinates in semantic space. Let me, okay. So just look at this one. So then I will go back to example. The message is order late aaya, okay? And then this order late aaya will be represented into a long series of numbers, which okay, vector, okay. Delivery बहुत late थी, which is again represented as vectors, and bhature soggy थी, which is represented as another vector. So as you can see, the first two, which is order late aaya and delivery बहुत late थी, which is corresponding to one intent, which is late delivery. So because these two concepts are similar, these two messages are similar, they will be put in the same kind of bucket or same kind of cluster. Okay. The third vector, which is about quality, bhature soggy the, it is expressing a different intent. Okay. So it will be put in a different kind of cluster. Okay. Do you understand this part? Because understanding this is very important. It has a lot of power. For example, late aaya, delayed, der se aaya, no matter what you use it, whether you use it in Kannada or whether you use it in Tamil or Japanese, all of these things which are complaining about late delivery, they will be put very close to each other in the intent cluster. Okay. Once we classify this intent, we can actually route our complaint to the right agent. Okay. So if the message have similar meanings, their vectors will be close. If the message has different meaning or different intent, their vector will have a distance. So this is what you want to understand, that embeddings capture meanings and not just words. And this is our first AI concept that we need to understand. So embeddings capture semantic meaning regardless of Hindi, English, spelling mistakes, informal tone. Basically, this is what we need if we want to actually do AI at scale. Is this clear to you? Please ask me questions. There are no dumb questions. If this is not clear, this might be difficult to carry on in the future, because these concepts build on the top of that.
Hi Raghavendra, Aditya here
Yeah.
again.
Yeah.
So basically, embeddings, you are saying that LLMs capture embeddings of a group of words or phrases, is what you're saying.
Mhm.
I think so. Basically, embeddings are for words, right? Like similar words will be grouped together, or
It's
is
not
it
about
for?
words. It's not about words. For example, sentences also. I mean, it has to have, yeah. So please don't limit yourself to words.
Okay, so let's say if I pass a sentence,
Mhm.
we will take the same example like order later at chole bhature thanda tha or something.
Mhm.
Then the LLM will go, it will parse the entire, like get the context of the entire sentence first and then break it down into two parts based on how does this happen in
Yeah,
backend? Like,
right. So basically, for the same sentence, which is expressing multiple intents, we are trying to do intent classification, right?
Mhm.
Yeah. So what you said is more or less correct. That yeah, for the same sentence, it will be parsed and different intents will be extracted or classified and put it in different clusters. Yeah. So that is right.
Okay.
Yeah.
But then how does the LLM know that okay, this is one part of the sentence, this is the other part of the sentence?
Yeah, so that's how LLMs are trained on a very planet scale data now. I mean, almost all the data from internet is actually used to train. So LLMs, the way LLMs are trained, they okay. Uh, how LLMs get this? Basically, it gets it from the data set on which it is trained on. So of course, it understands that part. Yeah, so that is that. It's in its training data. Yeah,
Okay, got
yeah,
it.
yeah.
So it initially when the LLM was trained, probably because the LLM is trained on such massive data that it has encountered some similar meaning sentences and all, and it has classified it into different what do you call it?
Not
Different
doing the
meanings.
training
And
part, not doing the training part. See, here what we are doing is for each sentence, for example, order late or order got delayed, right? So
Mhm.
in the semantic space, when we represent this as vector, and let's say if we say something the same in Kannada, the same language, or say same kind of intent, then whatever the vector representation comes out with, they are actually similar in the semantic space. because they are actually referring to the same thing.
Okay.
Yeah. So in this way, Swiggy does not need to anticipate every possible way someone might complain about food. They just need examples of old food complaints, and the embedding model will recognize that new variations are semantically close to those examples. So this is the fundamental shift from our rule-based systems. So for product managers, here's the key insight. Embedding models are trained. So there are different embedding models, and after this class, please go on Google or Hugging Face, where you can see different kind of embedding models. So there are embedding models for different languages, Hindi, English, Japanese, of course, and they are trained on massive amounts of text. So they bring knowledge about the language. So embedding models are actually knowledge about language, okay, that you don't have to teach them. But they are also general. I mean, of course, they don't know anything about Swiggy's business, right? I mean, they know what khanda means, and they know what cold means, and they know that khanda and cold are semantically similar, but they don't know anything about kind of Swiggy's refund policy or what actions they take, right? So embedding is just a first layer. Embedding is about the language. They help with understanding, but understanding alone is not enough, right? Understanding alone is not enough. We also need to understand what was discussed earlier in the conversation. So let's go to the next sub-problem. So I will ask one by one because some people are quite quiet. So Silky, do you have any questions right now so far?
No, I don't have any questions.
Okay.
I got the concept basically.
Right. Okay.
Yeah, fine.
Okay, cool. How about you, Rajan? And Nanda?
Raghav, I have one query. When you were mentioning that a single sentence can have multiple intent.
Yeah.
So the single sentence will have multiple embeddings also, and they will be put into both the intent buckets.
So okay, so you are asking basically if the sentence has multiple intents, which it has, then how does LLM kind of break down, let's say, kind of words belonging to intent one and words belonging to intent two separately? Is this what your question is?
Yeah, correct.
Okay.
And would the same word have different the mathematical values which you were showing? Can the same word have multiple different values basis the intent where it is being classified?
Yeah. So see, it's not about words, Sankal. It's about what also comes next, right? So, for example, trained. Yeah. I mean, let's use some words. I mean, depending on what is coming next, that captures meanings in a sentence, not just the word alone, right? So, as you know, LLM is trained on vast amount of data, and it's quite probabilistic in nature, right? Because it predicts the probability of what is the next word. Now, in that case, also, for example, when we, let's say, write a thing like, okay, order late aya, then that also has an embedding. Okay? Order itself, so it also depends on what is coming next in the sentence that represents kind of vector. So order late aya or order acha tha. Although these words both have orders, they will be having a different kind of vector embeddings, and they will be putting in different places in semantic map. Yeah. So yes, based on this kind of vectors, they will be represented differently in semantic space by the LLM itself.
Okay, understood.
Yeah. Okay. All right. Okay. Rajalingu, Nanda, do you have any questions, or can we move to the next sub-problem?
No, we're good to go.
Cool, perfect. All right, guys. Hey, so again, as I said, like basically, this is alone is not enough, right? I mean, bot also needs to remember what actually kind of was spoken earlier, which is remembering the context. So let's take an example of stateless problem. Okay, so traditional chatbots. Okay, let's just imagine a scenario that every customer support system faces. The customer starts with a chat. Okay? He can say, oh, okay, my delivery partner is at wrong location, and then AI can say, hey, I can see your order. Can you describe where you are? The customer replies, I'm near Blue Gate. मैं Blue Gate के पास खड़ा हूँ. या गार्ड के पास खड़ा हुआ हूँ. main entrance पे. Okay. And then AI responds that, hey, okay, can you try calling your delivery partner? then customer will say, yeah, I already tried, I've already tried, but he's not picking up. And then maybe after 1 minute, it just passes, and then customer says, hey, can you just cancel it? Now, here's the question. What does it refer to? I mean, and cancel what exactly? Of course, a human agent will automatically know the request is about canceling the order that we have been discussing for last 5 messages. But a state-based agent treats each message independently. For example, on this slide, as it says, message 1 says, my order is late. Message 2 says, can you help with it? So there has to be some kind of relationship between these 2 messages. If the AI does not remember one message from another, then bot's response will be help with what, right? Because it could not, of course, remember these things. Now, memory matters a lot at a scale. Yeah. So this is a conversational memory problem, and it is one of the reasons why pre-LLM chatbots felt so frustrating, because this pre-LLM chatbots, they had no memory. And as you know, right now, I mean, all of you are using chatbot, ChatGPT or Claude or Gemini these days, you know. And you understand that there is a kind of memory limitation. Like maybe after a lot of conversation, the chatbot will start forgetting what happened earlier, right? So this is called as the memory. Okay. Now, modern generative AI systems solve this with context windows. So whenever you send a message to LLM, you don't just send the latest message. You send the entire conversation history or a substantial chunk of it. So LLMs see everything that has been said and then can understand pronouns, preferences, references, and implicit context. But here is a catch, okay? And the catch is that context window also has limitations, and this is measured in tokens. So those who attended first lecture, I mean, I have spoken about tokens, but tokens is just for a rough tool of understanding. Just imagine tokens as kind of 4 characters of text, okay? So some LLMs have context window 4,000 tokens, some have 8,000, 32,000. These days, some even have like 128,000 tokens. But this sounds a lot, right? But the customer conversations can get long, and you have to, of course, include them in system prompt, documents, and other context. Now, अगर हम स्विगी के स्केल की बात करें, तो स्विगी के स्केल में लार्जर कंटेक्स्ट विंडो, जितना ज्यादा कंटेक्स्ट विंडो बड़ा होता जाएगा, उतना ज्यादा कंप्यूटेशन ज़्यादा होता जाएगा, which means if the chat history is long, then there will be a lot of latency and higher cost. Okay, so there is actually yeah. So for example, I want to talk about this slide. So let's say if the conversations become very long, then it will take a lot of time for the bot to answer your question, but our metric is that every query should be answered within 500 milliseconds, or let's say half of a second, right? So of course it has to be very, very fast, and they have to actually make kind of careful trade-offs in this case, which we will discuss later, right? So let's just imagine what kind of conversational memory is there. So of course we have this context window where last n messages are stored. We have to have different components like entity tracking, kaun sa order kiya hai, what were the items in that order, what is the amount paid, what is the resolution flow. So all this goes into the conversation memory. Okay, and we can have short-term memory, we can have long-term memory, and we can have system memory. System memory mein basically all these things about order, delivery partner, which restaurant has been ordered, goes into there. So depending on the requirement, things go in different kind of memory. Okay, but AI has to remember these kinds of things. In the conversational AI, we used short-term memory, which is context window to ask follow-up questions, multi-step tasks, natural language flow. Okay, and long-term memory for personalization and preferences. So as a product manager, you have to ensure what goes into what kind of memory. Okay, let's say if I'm vegetarian and I personally I can't eat that much of spices actually, and generally whenever I order from Zomato, I always have written in the comment box, which is written ki you can ask them, and I always say, hey, please don't make it spicy, or make it as or less oily or something like that, right? Then I expect the bot to remember, because I don't want to put all these things. I mean, that's what hyper personalization means, right? So some things should go into long-term memory, some things go in short-term memory. And of course, we have to use memory in a very optimal manner because we can't have too large context windows. So Swiggy's team, so I will be giving a link. I'm sharing this one, as you can see on the screen. This blog, basically Swiggy's engineering team, they described that they had to make careful trade-offs. They could not just dump the entire conversation into every request. They had to extract some key information like order ID, identified issues, customer segment, etc. sentiment, etc., which could be parsed efficiently. And this is what we call a stateful agent. It maintains the state across different terms of conversation, but it does so efficiently by extracting and summarizing rather than passing the raw history. So for product managers, for all of you, the key decision is how much context is enough. If you give too little context, then AI will forget important details, right? If you will give too much context, then you will simply blow your latency budget. So this is an architectural decision that affects both user experience as well as infrastructure cost. So please always remember that there are different kind of LLMs with different context windows, with different kind of token cost, but it's not always about cost. Maybe your company can pay the money, but what it cannot afford is that it cannot afford to frustrate your end user, right? Okay. So, all right. So this is something once, yeah. So as you can see here, ChatGPT 3.55 में some limited tokens थे, standard GPT-4 में 32 tokens हैं, right? So Swiggy's channel has been to fit the conversation history, user data, and policies, etc. in one window. Okay. So policy could be, let's say, if you ask for refund, then of course it has to check the refund policy. Everything has to be put in one window. Yeah. So there is a latency trade-off. More context will give you better understanding, but the time will increase to, let's say, 2 seconds. Okay. But you don't want 2 seconds. You want lower latency, but then the token size also decreases. So ऐसी स्थिति में आप क्या करोगे? Okay. You also want higher accuracy, but you also want faster response, right? So you have to make the right balance. So this is where our different concept comes from. So the third concept that comes from is basically how we can find the right information to solve the right problem. Okay. Because if we do not find right information, we cannot pass right information to the LLM, and then the context will be silently very big, okay, which we cannot afford because of cost as well as latency considerations. That is where our third problem comes, which is about knowledge grounding. So for all of you, is it clear that why memory was important and what are the limitations of memory?
Yeah,
Hi,
yes.
Ravendra. It's clear on why it is important. I just have one more question regarding
Yeah.
memory. Is it fine? Okay. So basically, as you mentioned, that context window has limited size, right? And we have to take a call on whether we want to have it like a short-term memory or a long-term memory. Let's say if and you also mentioned that LLMs are stateless, right? So uh, every time I make a call to an LLM, so my chatbot will be the interface, right? Backend, I'll be calling some LLM, right? Now, every time I make a call to LLM, the chat length will keep on increasing, right? Because the
Yeah.
user will keep on asking questions. So my tokens will just keep on increasing, right? So I mean, so the longer the chat, the costlier it gets for me for
Yeah.
each and every call, is it?
Yeah. Yeah. You're right.
So how do companies actually go around this? Because then this will become, and even let's say if Swiggy is one app, but then if I had some other app which for which I had done some transaction or had some query some 2 years back, right? And I had stored it somewhere in my database. Now for those systems also, I'll have to get there and get the 2 years transactions and then send it to the LLM. How do companies usually go about, reducing the cost? Because then it will just keep on increasing, right?
Yeah. Yeah. Good question. You tell me the answer. What do you think?
And one of the things that I was thinking was probably summarize, ask LLM only to summarize it and then send a summarized chat.
Yeah.
I mean,
Cool. You are
data
right.
to.
Exactly. So I will take one by one. So see, yeah, you are right. That LLMs themselves are stateless. You know? Now,
Yeah.
each API call is different. The model has no memory of previous calls. Model itself has no memory of previous calls. Yeah. The weights
Yeah.
don't change between requests. But you have to understand this memory illusion is created in the application layer. Okay. So you means you or your application, you store the conversation history. Okay. And you pass that history into the context window with each request. Okay. And LLMs read the entire context as if it is seeing it fresh. So her request may LLM is seeing the entire context as if seeing this fresh. It does not remember, it just processes everything that you have included, right? So traditional chatbots were stateless. Now LLMs have conversational memory, and that's slightly, I mean, that's there, right? So LLMs are stateless. LLMs, these systems themselves are stateless. That's why we have the concept of this context window, which are large enough so that you can pass substantial conversation history, creating the effect of memory. Okay, and that's where the cost actually keeps coming. Yeah. So the more the context window, bigger the context window, or more the context window is used, of course, you have to have more and more cost to that, and there will be larger latency. So that is where the challenge is, and that is what we actually solve. And how we solve it is actually we will be discussing it in next section.
Okay.
Yeah. All right. So that is where we need to do knowledge grounding actually. Okay. Now let's look at the stakes at Swiggy. Okay. So Swiggy now understands the customer wants a refund of cold food and it remembers the conversation context. Great. Now the question is, let's say if I order from let's remember the I mean Sardarji Ka Dhaba. Okay, maybe this is one of the whenever I come to Hyderabad, my friend circle takes me to that place. It's a nice place, right? But if I want a refund, maybe from that restaurant kind of return policy might be different from some another restaurant, of course, right? So how does AI actually know that restaurant's policy, refund policy, or how does that AI actually know Swiggy ka refund policy? Yeah. So if you take a base LLM, say GPT-4 or Claude, and ask, what is Swiggy's refund policy for cold food? It might give you something, and it might even look good, but it might be making things up, right? It might be hallucinating. Why? Because LLMs were trained on internet data from a certain date. It might have seen some articles about Swiggy, but of course, it definitely does not have access to Swiggy's current internal policy documents, which might be updated once every quarter, or it might be updated every month. We don't know, right? So this is the fundamental limitation. So LLMs are frozen in time at their training date. So they don't know your organization's specific information. You might think, can we not just fine-tune the model on our data? I mean, everyone will say, executives will also say that, okay, you fine-tune the model. Yeah, of course you can fine-tune the model. But it is very expensive, and it takes like a lot of compute power, a lot of competent people. It takes weeks, and if you take that route, then you will have to retrain every time there is some kind of policy change. I mean, we cannot do that, right? So, and there is also kind of phenomena called as catastrophic forgetting, which means that whenever you train on new data, the model can forget things it knew before. So that is where we come with a concept called as retrieval augment generation, RAG, R-A-G. Please remember, it is a very popular word, and you need to know a good deal about it, right? So this is one of the most important architectural patterns in production AI systems. Okay, so think of, okay, so maybe, yeah, so hallucination problem is, what's your refund policy for cold food? Okay, now LLM without RAG, we offer 100% refund. Just give me 1 minute. Give me 1 minute. Hello, can you hear me now?
Yeah.
Yeah, okay, cool. All right. Yeah, so for example, when customer asks, what's your refund policy with food? Okay, so without RAG, the LLM can say, okay, we offer 100% refund or 50% discount on next order of cold food complaints, right? So there could be hallucination, of course, because basically the policy it is quoting might be wrong. It might be just making stuff up, right? So here, think of RAG as an open book exam. Okay? When an open book exam, okay, let's say in closed book exam, it always relies on the training data memory, which might be from the training data which when LLM was trained. And it may misremember details, confident, but it could be wrong, and there is no way to verify, right? And here, when you implement RAG, so you take all your organization's knowledge, for example, policy documents, FAQs, product information, past resolved tickets, and you can convert them into embeddings. which we just discussed in section 1, right? And you will store these embeddings in a specialized database called as vector database. Okay, so whenever a customer asks a question, so let's just see how RAG works actually. Okay, so for example, customer is asking a question called as, hey, can you give me refund for missing dessert? Okay, and then this question will be converted to vectors. Okay, and then this question, this vector, so of course there are policy documents that are also in vector form. So there will be a vector search, and top 3 relevant policies are kind of extracted, which they are actually sent to the prompt along with question, retrieve policies plus instructions, and a very factual grounded answer is given. Okay, so the grounded answer could be, hey, per policy 4.2.1 missing items eligible for item level refund. Okay, this is basically is coming from RAG. Okay, so what we do is, the beauty of this approach is that LLM does not need to memorize your policies. Okay, it simply needs to read them at query time. So if your refund policy changes tomorrow, and if you update your document in vector database, then at very next customer query will use the new policy. Okay, is it clear right now? So for example,
Is
in
it sorry.
yes,
Is it same for all kind of applications? Is it like a principle kind of,
yes.
or
I mean,
does it
RAG is
differ?
no. Sorry, I mean, if I'm understanding you right, is that, are you saying that, hey, is RAG a very standard technique? Is this your question?
Yeah,
Yes,
right.
RAG is pretty standard. It is how it does. I mean, all the documents for, yeah, sorry, go ahead.
And the steps you have shown, like 5 steps and all, that is applicable for each and every application, or based on the scenario, does it change?
More or less it's same. Of course, I'm simplifying in some, you can have it like 7 steps also if I'm simplifying it, generally speaking, but yeah, it's a standard thing. So whatever queries you ask, irrespective of which use case it is, it will be converted into embedding. It will, okay, so step 1, again, before, so let's say in step 1, when you create thing, you take all your organization knowledge, okay, whether it is policy ka document, FAQs, product information, past experiences, things about user, you convert all of them into embeddings, and you store those embeddings in a specialized database called as vector database. Now, if you go online and search, hey, which vector database should I use? Of course, there are different metrics. You can use paid ones, you can use free ones, right? So you can use this vector database, just like you can choose whether you use SQL or MongoDB or Cosmos DB. You can choose. There are different databases. Then, in step 2, whenever the customer asks a question, you convert their question into embedding. In step 3, basically, you search your vector database. In step 4, you take the relevant documents, and step 5, the LLM generates an answer based on its general knowledge, जो कि LLM में था, and the specific documents that you have provided. Okay.
Okay.
Yeah. So this is a very pretty standard. Yeah. So yeah. Yeah. So even if you have like thousands of policies, it will have one source of truth. Okay. So basically, anything that is your organization-wide knowledge, you can actually put it in your vector database. Yeah. Now, of course, these things. So LLM isn't kind of just magic, and I want to mention that, okay, it has its own challenges. First of all, the retrieval quality matters enormously. Okay, someone has a question.
Yeah, I have a question.
Please, yeah.
So, sorry, going back again to the concept that it will store all the data, embed all the policy documents and all. Then, in that case, how it will support the short-term memory one and the long-term memory one? They are also related, right? I mean,
yeah.
In that case, because there will be huge policy documents, there will be like legacy documents and everything. How it will support in that case, sir?
Yes, cool. Okay, so let us take Swiggy's case and generally not Swiggy's case. Okay, so for example, in Swiggy's case, where you don't care about what was the policy maybe 2 months ago, right? You care latest because your order is like today, right? So in Swiggy's case, maybe for example, when policy changes monthly frequently or government rules change annually, let's say a promo codes rules that change daily, depending on the update frequency of the document, because we want to keep the latest, we have to kind of recreate these vector embeddings every time, right? I mean, the vector database has to be updated every time. But in many cases, for example, I only work in a company which manufactures some, let's say, some things which have a kind of a warranty of 10 years, for example, right? Then, of course, you need to store things which were legacy information as well, right? So this vector database has to be comprehensive and it has to be updated frequently. So this is, again, it has its own challenges, as you rightly can imagine. Yeah. Yeah, go ahead, Aditya.
Yeah, hi, Ravindra.
Yeah.
So, in the example that you gave for with RAG implementation,
Yeah.
basically, I just wanted to understand where all do we get charged? So, basically, let's say if I've asked something, now it will convert that into an embedding and vector, and it will search, right, all the databases that I have, right,
Mhm.
vector databases to
Yeah.
find the nearest possible set
Yeah.
of things. So, will LLM charge me for that as well? Any LLM? And then, see, I understand the last part where it is generating a text based on some prompt, the combined prompt that is there, it will charge. But for search also, does it charge?
Yeah, so basically, I'm just showing you something, a very popular database. It's called as Pinecone. Yeah.
Hmm.
So, for example, Pinecone, I mean, it is one of the most popular databases. You can see the pricing here. Okay. So this is the kind of databases we use actually. Okay. For creating such kind of vector databases. So somewhere the charging is definitely happening, right? Whether it is
Hmm.
charged at the LLM level or whether it is charged or no, or vector database level, retrieval level, then it depends. But yeah, charging is definitely happening. There are also some other kind of free ones. I mean, there is also from Facebook. So again, there are different implementations of vector database. It is a kind of open source library also is there. So yeah, charging is definitely happening, but you can choose to use open source one as well.
Got it. Got it.
Okay. So yeah, Silky, to your question, sorry, I forgot the last second part of the question. So yeah, the retrieved context is definitely passed to the LLM, and retrieved context is actually dependent on what is being stored in the organizational wide knowledge, which goes into the vector database. But if I have missed some part of your query, please ask again. All right, then I'll move on. Okay, so basically, hey, I just want to mention that RAG isn't magic. It has its own challenges, of course. So first of all, the retrieval quality, it matters enormously, right? So if you retrieve the wrong document, then LLM will give you wrong answer. That also, okay. And if you need good embedding models and good chunking strategies for your document. Sometimes the document might be, let's say, 1,000 page long or 10,000 page long, right? Then in that case, okay, so for example, let's say this one, there are thousands of policies document. There are like 50 plus categories of issues. There are 681 city specific variations. There are multiple language variations. So sometimes the retrieval challenge is like finding the right needle in haystack, and it's not that easy. Yeah. So for example, let's say biryani cold referred to Bangalore. I mean, that is the retrieval query. I mean, of course, precision is required. So what the bot must retrieve? It must go and retrieve, okay, general food quality policy, hot food specific rules, Bangalore city exceptions, and then it does not need to go into the looking at the wrong policies, okay? So if you get it wrong, if the retrieval quality is wrong, then you will get wrong answer at a scale, right? So basically, we have, as a PM, we have to make different trade-offs while implementing RAG. And there are three critical decisions. The first one is, of course, if you put more documents, then it will have better coverage, but it will also have potential confusion. So the top sweet spot is that you put top 3-5 relevant docs, okay? And knowledge curation, like your knowledge has to be updated very regularly. So the question is, who updates the knowledge base? How often do policies change? Do we have different version control and rollback? Okay, and of course you need to consider each stage in this adds a latency. For example, converting the question to embedding might take few milliseconds. Vector search might take few milliseconds. Document retrieval might take few milliseconds. So total overhead might be, let's say, 300 milliseconds in this case. But if you remember, the target metric that Swiggy set it for itself is that the answer should be given within 500 milliseconds. So you have to count in each step that where your time is getting consumed, and then you make a kind of decision. And you will have to make a lot of trade-off decisions actually in this case. You might have a kind of model which is giving great document retrieval, but it is also taking a lot of time. You might have a model which is great at handling kind of very real-time conversation, very human-like conversation, but it is bad at poor quality, poor reasoning, right? So you make a different trade-off depending on your business requirement, latency requirements, updating policies, etc. Okay, so that is that. So, so basically, generally, whenever you measure rank success, there are some KPIs that I want to give it to you that kind of matter. Okay, so for example, in case of accuracy, policy compliance rate, for example, should be more than 99%. Hallucination incidents, citation accuracy, because of course, if I'm citing a policy in the image, I cannot give a refund. Then it is much better that we kind of cite that policy and a proper auditing is done, right? So there are different metrics for accuracy, there are different metrics for performance, retrieval latency, document freshness, these kinds of things. So basically, there are different metrics for business as well. So of course, you don't want things to be escalated. You want first contact resolution. You don't want to have policy violation claims. So please, depending on the business metric, accuracy metric, performance metric, please decide which RAG tech stack you are going to implement. Don't just implement anything if you want to do enterprise grade AI at scale. Okay? So question is whether you actually build versus buy, and when you should build custom RAG. So actually, if you're really receiving like lakhs of queries daily, and there is a lot of domain specific knowledge, for example, medical knowledge, or Swiggy knowledge in that case, ki kaise unka business kaam karta hai. There are like strict latency requirements, right? Custom ranking needs. In this case, of course, you have to build custom RAG, but there are like also different kind of solutions available online, which is we call as managed RAG. So if your queries are not so much and the knowledge base is not so it's kind of generic, then you are flexible on latency, then yeah, please use managed RAG by your choice. So my recommendation to you is whenever you implement RAG, always try to start with a kind of managed RAG, okay? Because then you can quickly test it in like within a week, and then you can see whether your solution is working on these kinds of metrics, for like few weeks at least. Okay? And then if it is not working, then you go for custom RAG. So in case of Swiggy, they use Pinecone for vectors, the Pinecone I just showed you. They use some different ranking algorithm. They use different tier of caching, the deployment edges, etc. So this is that. Now, great. This is great. Now the thing is, this is where actually things get really interesting, and we will come to this before, but I will give some background. So, what is the distinction between chatbot and agent? Can someone answer? Okay, I'll pick names. So I'll go with each of you, Sankalp. Can you tell me what is the distinction between chatbot and agent?
I think agent, when one chatbot is generating some result and then giving it to another chatbot, then they can be called an agent. It means that there are 3-4 different tools who have expertise of their own. They are doing part of the work.
Okay, partially correct. I will clear it. Okay, I'll go to Rajalingu. What do you think is the distinction between chatbot and agent?
One more time, Ravi.
Yeah.
Can you repeat your question?
Yeah. Okay. What is the distinction between chatbot and an agent?
See, chatbot, it will give the answer which is already predefined, whereas agent is an intelligence system. It will take a little bit decisions and it will respond.
Okay, cool, cool. Good. Okay, basically, the thing is, see, our customer basically wants a refund, right? And now using RAG-based system, you also made sure key refund policy is correct. There is a clear citation, preferencing all these things. AI index understands that the customer is eligible for a refund. AI also has actually ensured that he will get a refund. Maybe AI can say that, hey, I understand you would like a refund, and I have noted your request, and our team will come and process this within 2-3 business days. Right? It will say. But that is not exactly what many customers want. I mean, they would be very happy if the refund is processed immediately, and they want a confirmation that it is done. So basically, they want AI to say, "Okay, I'm going to refund immediately," and then after it is refunded, they also want a confirmation that, "Okay, please check your UPI, your bank account, or original mode of payment that hey, it is kind of done, right?" So the agent is something which does not just talk about actions, agent takes actions. Yeah. And that is where tool use comes in. Modern LLMs can be given access to tools. Tools means functions that can decide to call based on conversation. So let's look at this one. Traditional. I understand your concern, please contact customer support. But agent with tools will say, okay, I have processed your refund of 450 rupees. So chatbot talks, agent acts. Right? Yeah. So just look at this one. Uh, please read quickly. I mean, okay, for example, uh, if chatbot response says, okay, please wait for callback, then agent will say, okay, I have scheduled a callback at 3 p.m. Yeah. So in that case, basically, agent will look at Google Calendar of the of its customer support agent. Agent will look at maybe the calendar of, for example, uh, the requester. Agent will look at different kind of.
Sorry, there is lot of background noise. Can we please mute?
Yeah. Okay.
Thank you.
So yeah. So basically, agent takes an action, right? So for example, chatbot can say if you want to ask chatbot, hey, my order is getting late, have a delivery agent. Then a chatbot will say, okay, you can track your order in app. Of course, you can these days also see ki kahan par hai agent maybe, right? Then agent will say, okay, order is 12 minutes away. I have notified partner. For example, at least in Zepto that I use quite often, it says ki order 4 minute mein aa raha hai, 3 minute mein aa raha hai. So this is like the agent's response, right? So the impact is that large number of queries get resolved without human intervention once we start using agent. So let us see what is the arsenal for AI agent. So there are different functions. For example, there could be functions for transactions. For example, refunding of refunding your money, applying coupon, cancellation of orders. There could be some tools that are related to information, which is checking your order status, delivery, fetching user history. There could be tools for communication, communicating to the delivery partner, communicating to the restaurant, sending SMS. There could be tools for escalations, escalation to humans, scheduling callback, creating tickets. So depending on the action which is required to be taken, there could be different kind of tools. Okay. So if there are, let's say, 3 intents or 5 intents in a message, then of course a different kind of tool calling will happen. So I'm estimating, let's say if there are like 200K daily conversations, then estimated average, there are estimated 3 tools call for each kind of conversation. Yeah. It could be related to escalation, communication, transaction, information, etc. So this is what agents actually enable us. Yeah. So, but basically we actually, so here is where product management actually really becomes crucial. Okay. The task a product manager always faces is कि which tools do you give AI access to? AI को कौन से tool का access देना है? हर किसी का तो नहीं दे सकते ना? And under what conditions can it use them? For example, you cannot give a knife, which is a very important tool to cut vegetables and cook your food, but you cannot give knife to a child, right? I mean, it's a useful tool, but you need to understand who should use them, under what conditions it should be used. Okay, and that is where things become exciting as well as risky. Okay, so for example, let's just look at this scenario. You always have to balance speed and value with safety. So for example, if AI can process refunds automatically, then what is the maximum amount? And what if the customer has already received 3 refunds this month? Should AI be like more skeptical कि ये जो व्यक्ति हैं ये हमेशा refund ही मांगते रहते हैं, right? Or discount ही मांगते रहते हैं? And what is the order value which is unusually high? I mean, these are not engineering decisions exactly, right? I mean, these are business decisions. So they basically are the kind of decisions product managers need to make. Yeah. Now, Swiggy's approach is based on their published architecture. They of course define careful boundaries, and as a product manager, you always will be looking into this autonomy spectrum. You actually have to define careful boundaries. So certain actions which are like a small refunds for common issues, of course you can fully automate it. If someone is asking refund for less than 100 rupees, 300 rupees, okay, fine, give it to them, right? And but if you have to process the refund of let's say 500 or 2000 rupees, okay, then in that case you need to confirm. And if there are refunds of large orders, like thousands of rupees, then, and if it is happening more often, then you should escalate it to human who can consider account ban or who can review it, and you can check legal policies, safety concerns, fraud detection, many of these things, right? So this is what we call autonomy spectrum. At one end, there is full automation, where AI decides and acts without any human involvement. On the other hand, there is full human control, where AI just gathers the information, presents the options, but a human makes decision. Yeah, full human control. So most of the production systems are always sitting in the middle. Okay, so with different actions at different points on the spectrum. So as a product manager, you need to define where each action sits, and you need to have a clear reasoning for those decisions. So this is very core to your job. I mean, this will take a lot of your time, of course, yeah, and talk to engineers and implement all these kinds of things. Now, the decision framework is that generally I use in my work is, of course, you choose the risk level, you choose the frequency, you choose its reversibility. Many decisions are reversible, many are not. And then you decide the automation level, right? So please look at this one. So for example, of course, there are things that you need to do, and this is I want to really talk about them, which is you need to kind of look into tool execution safety, okay? Which means you need to prevent expensive mistakes at scale. Now, if a user is asking multiple refunds in a week or day, you always can do the rate limit. You can say, hey, you already got refunded like twice within this week, then we cannot do this. I mean, you can limit the rate, right? Limit the rate in this case. Or you can, of course, limit financial risk by auto-approving only to a certain amount. You can, of course, validate that order belongs to certain user. You can basically do this audit training to track decisions, log every tool invocation, and you can, of course, you have to have a rollback mechanism so that you can fix mistake. For example, if the account was banned by mistake, then you can reverse the action, right? And this case. So I know many people who's like, let's say, WhatsApp account gets kind of locked or something, and rollback takes a lot of time. I mean, this should be faster, right? So there are many things that need to be done faster. Yeah. So let's imagine if there are like two lakh conversations happening, and if there is like even I mean averaging it out, of course, if there is like a 100 rupee loss because of one bug, then there will be 2 crore per day loss, right? So of course, with great power comes great validation. Yeah? So you need to validate at each step. Yeah? You have to have this kind of safety mechanism when you are using to use this tools in agentic AI. Now, another interesting thing. Okay, let's go back to our original message. ओरिजिनल मैसेज वाज कि भाई ऑर्डर लेट आया है, छोले ठंडे थे, भटूरे सौगी थे, मुझको रिफंड चाहिए, और अगर रिफंड नहीं मिलता है देन नेक्स्ट टाइम से कैन यू गिव मी डिस्काउंट, समथिंग लाइक दिस. So we have already spoken about understanding the intent classification. We spoke about conversational memory, we spoke about RAG, and we spoke about the tool use, right? But there is a big challenge, and that's also Sankal's original question comes in, I mean, here also. That the challenge is that we haven't addressed, that this kind of message contains multiple requests, right? So one is there could be complaint about late delivery. So this might involve checking delivery time stamps and potentially compensating for delay, right? There could be complaint about food quality. Food quality, this could involve different policies, potentially different compensation, and might affect the restaurant rating. That is also a risk. Third is the refund request. It is a straightforward action, but it needs to be coordinated with the other. Fourth is the question about feature risk common. This is basically actually about a loyalty or marketing question and not a support related question. Now imagine, just imagine, you are a LLM or you are an AI, and you are trying to handle all of this with a single AI agent. All of this with a single AI agent. Will it work? I mean, it might, but agent would need to understand all the 4 domains. Agent will need to understand the domain of lead delivery. Agent will need to understand about the domain of food quality. Agent will need to understand the refund request policies and future discount policies, many things, right? And of course, it will have to access all the relevant tools. Okay? And it will have to maintain a context across different topic threads. And it will have to produce a unified response that addresses everything. It's too much work actually for a single agent. Okay, so in earlier versions of actually Swiggy, basically they tried the single agent approach. I mean, I recommend you read this blog. So if you read this blog, they will talk about this this kind of agent, right? This agentic AI transaction, and they said they implemented first this single agent wala thing, okay, but it didn't work for these reasons because so we tried this agent-based approach, and they achieved about kind of 90% accuracy on routing and handling, but this sounds good if you remember that scale. So if you remember that slide, if you are doing 90% accuracy, then still you still have like 6 lakh frustrated users. I mean, right? You don't want to have 6 lakh frustrated users. You cannot afford that part. I mean, they will move to Zomato or some platform, right? So no, it won't work. So 90% accuracy on 200,000 daily conversations means 20,000 failures per day. 20,000 failures per day, a big number, which means 20,000 customers will get wrong answers. They might get inappropriate actions or frustrating experiences every single day. So their goal has been to get 99% accuracy, and last 9% proved incredibly difficult with a single-based approach, agent approach. So you will need to have a multi-agent architecture. Okay. So here is what actually you need to. So okay, move to the next slide. Yeah. So in single agent architecture, there is a customer query. There is one general agent that handles everything and response is 90% accurate. But when you do multi-agent architecture, customer query comes, then there is an intent router. Okay. So if the intention is about delivery, it is routed to different agent, it's quality different agent, a refund agent, loyalty agent. So every query is routed to different kind of agent. The response is orchestrated, and then the final response is 99% accurate. Generally, that is what they have observed. Okay, so there is this routing layer. Okay, so whenever a message comes in, a specialized router analyzes it, identifies the intent present, and then this would be tagged with delivery complaint, quality complaint, refund request, loyalty question. Then these are all specialized agents. So rather than handling one, instead of having one general purpose agent, Swiggy has multiple focused agents. Okay, delivery agent को delivery के बारे में सब पता होगा, quality agent will know about food complaints, refund agent will process compensation, loyalty agent will handle rewards and discount, right? And then there is a kind of orchestration layer. So whenever multiple intents are detected, this orchestrator kind of forms each intent to appropriate specialist agent, and then basically the orchestrator combines the response into a coherent, unified customer, right? So this is where this gets interesting. Please, once you get time, look into this diagram and read a little bit about it. Okay. So this routing is actually very, very crucial. Okay, and this Databricks blog, it reveals that giving routing decisions entirely to LLM achieved a lot of good accuracy, right? So solution was actually hybrid. I will look at show you this one. So ये routing भी हम सिर्फ LLM को नहीं दे सकते पूरा का पूरा. Okay. Yeah. So okay. So for example, in case of clear-cut cases, okay, let's say 70% of the queries, you can always do a rule-based routing. Okay. कि अगर ये delay order delay से related है delay तो उसमें दूसरे agent को दे. But in case of ambiguous queries, then you can do LLM-based routing. So please do not use LLM for the sake of using LLMs. Or if you can do the rule-based at any stage, then also use rule-based in this case, right? So their solution was a hybrid. For clear-cut cases, they do the rule-based routing, and for ambiguous message, they used LLM-based routing. Okay, and it seems they also kind of dedicated a lightweight LLM, which was fine-tuned specifically for routing. Okay, and this is how they achieved accuracy goals. So now, for product managers, multi-agent architecture is important to understand, as you can see, because this is how a complex production systems actually work. You are not deploying an AI, you are deploying a system of coordinated components. Okay. Any questions so far? Yeah. Okay, so you can quickly read. So for example, again, delivery agent is specializing in these things. Knowledge base is different. For example, for delivery agent, the knowledge base, which we discussed in RAG part, right? It could be partner data, traffic data, maps data. A quality agent, again, Silky, you also asked question related to this, right? कि अगर quality agent hai, then in this case, he does not have to care about the partner data. He only has to care about restaurant SLAs and item specs. Yeah. So loyalty agent has to only care about the user history and promo engine. So this way, we can also have a good impact on conversation memory. What is conversation memory to be maintained? What is the RAG database to be maintained? All these things, right? Because now we are narrowing the scope of each agent, right? So these specialized training on narrow domains can always lead, can generally lead to general training, right? Yeah. So this way, they could achieve the overall performance, which was of like 99%. Latency, they could achieve at like less than 400 milliseconds. Cost reductions was also there. Yeah, so all good there. Okay. Now, router decision logic, for example, again, coming to Aditya, your question, okay, if there is a refund inquiry, I mean, of course, intent based, not keyword based always, then you can target to different kind of routing, different agent or the delivery agent. You can write this if else kind of rules, right? Or LLM based rules also. You can write this. Now, another thing that we really need to discuss, okay? And this is very important, so I want to give some time there. Okay? LLMs can be confidently very wrong. Okay? And ask an LLM about Swiggy's refund policy and it does not have information. So it won't say, I don't know, but it will generate something very plausible sounding, which is called as hallucination. We covered that part. But still, we need to have kind of guardrails also, because even with RAG approach, the hallucinations can happen. And even a small hallucination rate can cause significant damage. Customers can receive wrong information, refunds are processed incorrectly, and so trust kind of erode, right? So how do you prevent errors in a system which is inherently probabilistic? That is where you need to put guardrails. Okay? So yeah, you need to build systems that basically know their limits. The best AI systems know what they don't know. Okay, please remember this part. Best AI systems know what they don't know, right? So in case of, there are 5 essential guardrails you need to use. So for example, first is always do policy validation. So for critical information like refund policies or terms of service, AI does not have to paraphrase. It should go directly from the approved policy documents. Of course, we enforce this using RAG system. Responses about policy must be traceable. Okay. Then we whitelist the information sources. Yeah. If a customer asks something which is not in knowledge base, then AI should not make it up. It will simply say, okay, I don't know. It should acknowledge the limitation and escalate if needed. Then it should have deterministic control on tool calls. It should have confidence scoring, and it should know when to stop and do the escalation, right? Certain keywords, sentiment patterns, conversation characteristics automatically should route to human agents. So for example, अगर किसी ने कहा okay, I will take legal action, and if someone is talking in a very extremely distressed manner, okay, or if there are repeated failures which bypass that, yeah, so basically it should actually be escalated to human, right? Hard limits in case of refund of, let's say, 5,000 rupees, more than that, escalate to human, right? So this is also always we have to make sure that we do when we do guardrailing. Okay. Now, of course, you can. How do you do that? So you are useful, very useful. So for product managers, okay, the key insight, as I said, is best AI systems know that what you don't know. So building AI is not about making AI smarter. It's not just about making AI smarter, right? It's about building AI systems that catch errors and validate outputs and escalate appropriately. So you can always put a confidence threshold, right? If confidence is more than 90%, then okay, you can auto act. But if confidence is, let's say, between this range 50 to 70, then you can clarify you can escalate something like this. I mean, this is always done. Yeah. So of course, this percentage will depend on your own business. For example, yeah, you can actually. I'll just quickly escape this one. Yeah. So again, as you can see, the business impact. This is an example business impact. If false refunds happen, let's say only 2,000 per day, then maybe there could be like a reduction in loss, right? Which is a great impact. But escalation rate, I mean, all these things, false refunds, escalation rate, resolution time, customer trust, compliance issues, with guardrails, they will have a significant impact on your business. So never launch an application without putting guardrails. I mean, I have seen so many engineering teams not putting guardrails appropriately, and of course they suffer. I mean, it shouldn't be like that. Okay, yeah. Someone has a question. Silky, yeah. Hi.
Yeah, hi. So, one thing I need to understand, if we are saying that the cost benefit analysis is there, right? And we are getting the data, say for if I talk about the Swiggy, right? Maybe there will be not even 1,000, but maybe lakhs of requests every day. So there should be a period for these analysis also, right? Or is it a
Yes.
continuous thing that for each and it can't be on each and every request, right?
Yeah, you are correct. You are correct. Yeah, yeah.
So how do we ensure that, I mean, there might be few requests which are not even relevant, or like how do we ensure that this analysis is keeps going? And in that chart where you have shown vector, then we have ground response and all, where does this analysis come, or there is a separate agent for this one, or separate LLM for this one?
Good question. So actually, you can do it in that manner as well. And I mean, okay, let's put it in this way. For such kind of, let's say, confidence scoring, okay, first of all, everything has to be auditable. Okay, and everything has to be logged. So in many cases, uh, auditing or kind of checking will not happen immediately, right? Whether guardrails are met or not, but that is where actually we need to continuously monitor. And with this scale, this becomes difficult. So of course, you might use another agent in that case, but that's why I mean these kinds of things roll out in a phased-wise manner, right? So that you don't raise kind of release this application to 2 lakh users or 10 lakh users at the same time. Maybe you release to first 10,000. You see where it is, how it's working, and you see this impact, right? Without guardrails and with guardrails, and then you release it to more. So it's a phased release. This is one approach. Second is, of course, you do auditability, you do logging, and if you can manage automation of this auditing, that is great. That is basically they would be targeting, but generally start with manual evaluation first.
Oh, okay.
Yeah.
Okay.
So I mean, of course, you do ROI calculation, and then the guardrail development में इतना हुआ है, monthly savings इतनी हुई है. Sometimes savings can be measured in dollar value, sometimes it cannot be. What is the payback period? All these things you do, right? Sometimes you cannot put guardrails if the ROI is too less. Then so basically, generally, without releasing. So the point is, guardrails are not restrictions; they are trust builders. So of course, you put them and you continuously monitor them and you continuously evolve with them. So this is how actually a system, enterprise system, should be implemented. Right? So the 4 version evolution was that basically. Okay, I want to talk about this because this is so important. So this evolution is very instructive. I mean, it shows how engineering decisions connect to product outcomes. So each version solved some problems and it revealed some new ones. So understanding this progression actually will really help you anticipate similar challenges in your own domain, own products, right? So for example, the first version was single LLM. I mean, if you look at this one, so the first version was single LLM and 2-tier intent. Okay, in this case, it understood the language, but it did not understood the. Okay, it was very naive. I mean, the first version was conceptually simple. They took a large LLM. They will pass the customer message to the LLM, and LLM will of course generate the response. And then, it handled the language variation better than keyword matching. It could understand the paraphrases, synonyms, etc., and it could generate the natural language responses. instead of can template. But there were different problems. For example, there was a hallucination problem. Uh, LLM did not know the Swiggy specific policies, and it will make some refund timelines that were wrong. Uh, Basically, it would promise things that Swiggy couldn't deliver. It was okay. Secondly, it was purely conversational. So LLMs could talk about processing a refund, but it could not actually process one. So customer will have a conversation, but nothing would happen. I mean, they will have to call support anyway. Also, there was memory was very limited. So early implementations didn't handle conversation history well. AI would ask customers AI would ask questions the customers had already answered, and intent was poor. Multiple intent was poor. So, agar multiple intent say question, and then they would only get partial responses. Then they moved it to LLM plus RAG, in which they added RAG pipeline to the intelligence layer. Now, what did it solve? So, of course, the hallucination problem significantly reduced. Okay. So, if customer is asking about refund policies, Swiggy ne bata raha. Okay. Swiggy specific information, AI became very accurate about. But there were new problems. Retrieval parity was poor. Action problem, koi action lene wala nahi tha wahan par. I mean, AI would describe what should happen, but it will not take any action. And still, multi-intent agent was still kind of weak. Yeah. So this is one of the problems were there. Okay. Now they moved it to version kind of 3. So version 3 was an agentic breakthrough. Okay. Here they introduced some kind of tools. So there was action also, and there was also a response also. Okay. Now it can act. Okay. But this also created a problem. The problem was whenever the message was very complex, that means whenever the message was having multiple intent, accuracy dropped. तो एजेंट क्या हो रहा था एजेंट गॉट कंफ्यूज्ड कि मुझे कौन सा टूल कब यूज करना है इट वुड प्रोसेस रिफंड प्रोसेस कर देगा बट देन इट विल फॉरगेट एन आंसरिंग अबाउट द फ्यूचर डिस्काउंट फॉर एग्जांपल और या सो basically the Databricks blog it mentions that okay giving agent assignment decisions entirely to LLM achieved 90% accuracy but the goal was 99% right तो उसके लिए हमें क्या करना रहा okay you had to do specialization. You had to actually do multi-agent architecture. Yeah. In this case, they adopted an approach of divide and conquer, right? In which instead of one agent trying to do everything, a specialized agent handle a specific domains. And of course, I talked about orchestration and all these things. Right? So, whenever a new capability, this was also scalable in a sense like, अगर Swiggy ने नया capability add किया है, that means they will keep adding new specialization.
Hello.
So debugging became very easy. I mean, if there is a problem with refund, they will simply go and do the auditing part for the refund. So again to your question, auditing logging का काम भी यहाँ पर आसान हो गया, right? Because they could say कि okay, based on traceability, refund agent didn't work as properly. Yeah.
क्या order
So,
किया था?
you can do debugging much easier. Again, what I wanted to emphasize, why did I show this evolution? The reason I showed this evolution was basically they did not build version 4 from day one. They built the simplest thing that might work, learned from its failures and iterated. So each version taught them something they needed to know before they built the next version. So again, as a PM, you need to resist the temptation to discuss a lot, think a lot, make a perfect system upfront. I mean, don't do that. I mean, so many PMs and so many departments do that. I mean, there is no perfect thing. So please start simple, ship, learn, iterate, release in phases so there is minimum impact. Of course, do the cost benefit analysis and all these things, right? So, okay. Great. So this is what it is, but I wanted to talk about. I think we have covered all these topics, seven things here. So, but I would like to, yeah. So you need to actually decide what is the autonomy spectrum. You need to look at different options and then you make a decision, right? So I would like to close here this session, but I would like to recap that what we have covered in this session. Okay. So we use Swiggy's customer support system as an anchor case to learn 7 core generative AI concepts. Okay. First, we learned about embedding, semantic understanding. We learned how AI systems understand meaning and not just word. We also learned about conversation memory, context windows, how AI remembers what was said earlier. We learned about RAG and vector databases, how systems retrieve relevant information from knowledge bases. Then we learned about tool use and agentic behavior, right? How AI systems take actions and not just generate text. We learned about multiple agent architectures. We learned about different vernacular NLP and localization challenges. We learned about guardrails and confidence scoring. We also saw the Swiggy's evolution for different phases. And we discussed the PM's role, which is defining success metrics, setting the autonomy spectrum, prioritizing capabilities, designing escalation triggers, managing knowledge bases, designing for failure, putting appropriate guardrails. So all these seven concepts they are not specific to Swiggy. They will virtually appear in every production generative AI system. Okay? So in our next session, we will look at Klarna, which is another case study. Uh, we will look at its success and failure. So I would like to give you a little homework. I mean, please do this one. I mean, please look at customer support interaction that you have had, maybe with your bank, with your app, or anything, and try to map that interaction to this different sub problems that we have mentioned. Okay, and you need to think, I mean, which parts were handled very well, which parts were frustrating, and which generative AI concepts might have helped you there. So please look at this, bring these observations to the next session. You can always message me on WhatsApp. I mean, so that we can make this session more interactive next time as well. And if you have any questions, please let me know. We will have some general room for discussion right now. Aditya, go ahead.
Yeah, hi Raghavendra. I might have missed it in the session, but can you explain to me, like, with regards to multi-agent systems, that the last
Mhm,
slide that you showed, right?
mhm,
Having specialized agents for specialized tasks.
mhm,
Uh, does it like do we want to build it like that, or have one agent which can access multiple tools? I'm asking this purely from a perspective of, let's say, is the context shared among different agents, or because if one agent specializes only in refund, the other one in, let's say, late delivery and things like that, wouldn't it be a problem, like sharing the context, or will it be shared across different agents?
Yeah, I mean, okay. Yeah, you missed that part. Because I covered that. I'll cover it again. Look at this one slide, right? So basically, you don't need to cover all the context, right? I mean, you just need to orchestrate. Okay. So let's say customer query comes, okay, and then there is an intent router. So intent is sent to different agents, okay. And now let's look at different examples. So in this case, one agent, a specialist agent, will be able to do this in a much better manner. Okay. Yeah. So for example, quality agent, refund agent, loyalty agent, etc. And after they have done their work, all they need to do is do the orchestration so that the final response can be sent. Okay. So if the intent is different, then basically it is much better we pass it to different kind of agents. Because if you give, as I discussed, I mean, that is what Swiggy implemented in version number 3. Yeah. They gave all the intents to one LLM and it might forget to use some, it might do some tasks. So the behavior was very suboptimal. Yeah.
Okay. So it's always better to have, like, for some specific tool, have some specific agent rather than having one agent which can access multiple tools.
Yeah, I mean, try for your application. The one of the reasons I showed through this multiple kind of evolution is that you shouldn't jump to V4, which is multi-agent architecture at once. Try using a
Hmm.
single agent architecture first, right? Who knows? It solves your problem. Maybe you don't have that many tools to call from. If you have, let's say, only 2 or 3 tools, it is still fine, right? But if you have, let's say, 100 different tools, which in this case, for example, let's say, different kind of maps are there, even for delivery agent. Different kind of restaurant SLAs are there, different cities, different languages.
Hmm.
If the complexity is not so high, maybe your tool set is also limited now. So try for single agent first, which is simple to implement. Then go with
Hmm.
multi-agent. And you take these decisions depending on case by case.
Got it. Got it. Cool. Thanks, man.
Sure, sure. Any other question? Nanda, Silky, Sankalp?
No,
None from my end. Just one request. Whatever the topics or homework you have just now asked us to go through, so can you please put in the chat as well? Uh, in our, I think, WhatsApp chat or somewhere.
Sure, I'll give you that. Yeah.
Yeah, thanks. Yeah.
Also, Raghavendra, if you can send that link, the Swiggy case study that you have.
I'll send the link. Yeah.
Okay.
Or you can simply type Swiggy Databricks. I mean, on Google, right? It's just Swiggy Databricks, it is this case study defining the customer support, right?
Okay.